This lesson is on logarithmic functions. Today we're going to look at learning target 2.6 that says I can graph logarithmic functions using transformations. So the first thing that we need to remember is the definition of our logarithmic function. A logarithmic function to the base a, where a is greater than 0 and a cannot be equal to 1, is denoted by y equals log base a of x, and is defined by the fact that the logarithm y equals log base a of x is true if and only if a to the y is equal to x. Now we learned this in the last video. We looked at the fact that we could change from logarithmic form to exponential form by saying a to the y is equal to x. The domain of the logarithmic function is always x is greater than 0. The x here must be positive. It cannot be 0. It cannot be negative. This number right here. The logarithm as the inverse of the exponential. This is very important for our graphing purposes. If I want to graph f of x equals 3 to the x, I want you to notice that the base of 3 is greater than 1. 3 is greater than 1. If I were to pick some x's to plug into this function, like -1, 3 to the -1 is equal to 1/3. 3 to the 0 is equal to 1. 3 to the 1 is equal to 3. If I graph those points, here's what I get. -1, 1/3, 0, 1, and 1, 3. When I graph this, this function is going to start out over here toward negative infinity, and it's going to never, ever, ever touch this x-axis. It's going to get very close to it over here, but it's never going to touch it, and then it's going to rise up rather rapidly on this side. We've learned about these exponential functions in the last unit. If I want to graph the function f of x equals log base 3 of x, again, notice that the base of 3 is greater than 1. This is the inverse of the previous graph that we looked at, 3 to the x equals y. Since they are inverses, all I have to do is switch x and y. So instead of -1, 1/3, I have 1/3 -1. Instead of 0, 1, I have 1, 0. And instead of 1, 3, I have 3, 1. When I graph this function, positive 1/3, -1, 1, 0, and 3, 1, I want you to notice that now this function is getting closer and closer and closer to the y-axis. If I want to graph f of x equals 1/3 to the x, notice that the base here is between 0 and 1. If I plug in -1, I get the reciprocal of 1/3, which is 3. If I plug in 0, I get 1. If I plug in 1, I get 1/3. Graphing those points, I get the exponential that is decreasing and getting closer and closer and closer to the asymptote of the x-axis right here. So y equals 0. If I'm going to graph the log base 1/3 of x, here notice that the base is between 0 and 1, then what's going to happen is I'm just going to switch my x and y from the previous exponential. So I'm switching x and y. 1/3, 1, 1, 0, and 3, -1. When I graph those points, again, I can see that the y-axis, which is x equals 0, becomes my asymptote, 1/3, 1, 1, 0, and 3, -1. This is the log base 1/3 of x. Properties of the graph of the logarithmic function. Number 1, the domain is the set of all positive real numbers. We just mentioned that a few minutes ago. This x must be positive. The range is all real numbers. Y can be positive or negative or 0. Number 2, the x-intercept of the graph is 1. There is no y-intercept. It will never touch the y-axis. Number 3, the y-axis is a vertical asymptote of the graph. Number 4, a logarithmic function is decreasing if a is between 0 and 1 and increasing if a is bigger than 1. And number 4, the graph contains these points, 1, 0, a 1, and 1 over a negative 1. These are your critical points. You must know them. This is your base. This is the reciprocal of your base. The natural log, we've talked about this before, is y equals ln. That's the natural log of x. And that is true if and only if x is equal to e to the y. The natural log has an understood base of e. So if we wanted to graph f of x equals the natural log of x minus 3, we want to also determine the domain and range and the vertical asymptote. Well, the first thing that we're going to do here is we're going to graph f of x equals the natural log of x. Well, we know that 1 over e, the reciprocal of e, and negative 1 is a point, 1, 0 is a point, and the base e and 1 is a point. Now, what we're going to do, this is 1 over e right here. This looks a little funny. That should be 1 over e. I should probably go in and fix that. We know that this 3 right here means that we're going to add 3 to all of our x's. So we're going to say 3 plus 1 over e, 3 plus 1, which is 4, and 3 plus e. The y's remain unchanged. 1 over e, if you go to your calculator, you'll find that 1 over e is about 0.4, and then 3 plus 0.4 is like 3.4. So I've got 3, almost 3.5, negative 1, 4, 0, and then e is 2.7 approximately, so 3 plus 2.7 is 5.7 about, and 1. Now, the thing that I need you to remember is that because this moved left and right, it's a horizontal move, it didn't move left, it moved to the right, but inside the function is a left or right move. That means that my vertical asymptote is also going to move left or right. In this case, the vertical asymptote moves from the y-axis over 3 to the right, so now my vertical asymptote is here at x equals 3. The domain here is all of the x's that are greater than 3 or from positive 3 to infinity. Notice that we cannot include the 3 because we'll never touch this x equals 3 line. The range is all real numbers because this graph does go down forever and it continues to go up forever. And the vertical asymptote is x equals 3. The common log is a logarithm with base 10. LOG is true. Log base 10 of x equals y is true if and only if 10 to the y is equal to x. Now, what I'd like for you to do is I'd like for you to try to graph each of these, state the domain and range, the x-intercept, and the asymptote. The natural log of x plus 5 and f of x equals 2 times the log of x minus 3. And then we'll talk about those. After you've done those two, I'd like for you to try these two and see if you can graph them as well. Tomorrow in class, we'll talk about those 4 graphs that you just tried to graph on your own.